It's time to get our device fired up so we can actually use it from a smartphone or web app. And in order to do that, we're going to use the MQTT messaging system. It's just a kind of a publish subscribe so that we can have our device basically when the light turns on, we're going to publish an event, a topic, and we'll have our phones and web apps listening for that so we can do the UI changes. And likewise, when we push a button, have the device listening for those types of things too to react. So a lot to read about that. If you care to read up on it, there's more on the internet. I won't go too far in depth on that. But what we'll be using for our broker, I found a free CloudMQTT hosted in the cloud. It's free to use. You can host your own MQTT broker if you wish to. I just found that this was a quick way to get off the ground and running. Their documentation is available online, and because there are just a few like password type things when you create your account, I figured it was just easier to use their documentation and just go through the first things of what you need to do to get set up. So if you go to cloudmqtt.com, you'll create an account, and then when you get into your account, you'll need to create a new instance. Inside of that, you'll have to select your plan. There's a cat plan, which is free. So I would definitely do that. The name, I just called mine Switcher. You can call it whatever you want there. And then you'll go on to selecting your region. The region for cat, it only gave me two choices, but only one of them worked, and that was Ireland. So if you're in the US, hopefully you can get something in the US. Otherwise, I guess you just go with whatever one they give you. And then at that point, your instance will be created, and you'll get to a page which will have your server, user, password, all sorts of things that we will definitely need here for when we get our device hooked up. So that being said, this would be step one. I would go through, get that signed up, keep this tab open, because we're definitely going to need it here in the next part. Okay, switching back to our Arduino. When we left off last time, we were able to get our light bulb to turn on and off, but we didn't have our internet functionality. So what we need to do is get connected to our Wi-Fi network, and then we also need to get connected to the Cloud MQTT broker that we just created. So the Wi-Fi examples I was able to find, they have already some examples here on how to connect to that, and they have a library available. So that's what some of this code is here with the Wi-Fi client, initializing it with our network name and password, and then basically code that just continually tries to connect. You can handle failure here if you want, but since since this is hard coded as my home network and password anyway, I figured I would just say, hey, just keep trying to connect until you do. The second remaining piece, the pub sub client, um, when looking online, I was able to find a decent library, had some good documentation on it. And in order to find the one that I used, if you go to Tools and Manage Libraries, we can take a look and just search for pub sub client. And it takes a little second. And you kind of have to scroll down too, at least for the one I used. There's one by Nick O'Leary. I picked this one mostly because I found some examples and it has some pretty good documentation on how to use this. So go ahead and install this library here, and that's where we end up getting this import, okay? So to go through the rest of this code, basically after we're connected to our Wi-Fi, we need to set our server, okay? So I hope you left that tab open that I told you to leave open. It's gonna have your MQTT server name and port, so you'll go ahead and fill those in here. And then basically you're gonna connect. You can have whatever ID you want for this specific device that you're gonna install this onto, but then you're also gonna need to pass in the MQTT, Cloud MQTT username and password here. And so this will handle getting connected to your client. After we're connected, we're going to want to subscribe right away. I just called my topic light. Basically, this would mean that like when I publish something, I'm going to use light as the topic. And then what happens when I receive something as I subscribe to that subscription, there's a function here that I created called subscribe received, and we'll go over that here in a little bit. So this is all within our setup. Basically, connect to the Wi-Fi, connect to our client. Time to take a look at what is happening inside of our loop. Now you're going to notice right here there's an MQTT client.loop. Now what in the world is going on here? Okay, well if we look at the documentation from Nick O'Leary, and this I will also post this in the video and the blog, that there's a loop function here, and this is just saying it should be called regularly to allow the client to process incoming messages and that kind of thing. So basically we went ahead and just put that inside of the device loop, is that it's also going to continually loop so we can receive those topics. Pretty much all of this code here. We didn't change a whole lot. I'll go into a little bit about turning the light on and off and the steps that we'll have to do here in just a second. The final part that I really need to go over in this is the subscribe receive. Now, I think I might have mentioned earlier that this gets called with the topic, but it gets called on any uh, publish from our MQTT, right? And so basically what we need to do is define what happens when we receive notifications from our MQTT server, right? So basically, we need to go through and figure out if the topic matches the one that we want, and then we'll figure out how to handle that from there. So we use a little string comparison on light to figure out if that's the right topic. Then we have to go inside of that payload to see if it's on or off. And so that's what all of this code is doing here. You could certainly use booleans, values of 0, 1, true, false, those kind of things. I just chose to use on and off more for readability. But certainly you can change how this is implemented. I guess at the end of the day, you just want to make sure that the payload, whatever gets passed in, deals with the logic of how you handle turning a light on or off. So basically then when we say turn the light on, what we do here is the same code that we had last time as far as physically turning the light on onto the board. But the other thing that we want to do is basically we also then want to publish another event. We're not going to use the same topic because then we would just be stuck in an infinite loop. But basically, the convention being that we're going to use the topic and then the state. This is basically saying the physical state of the board. And by doing this publish, this allows our mobile devices to, or if you have a web app and a mobile app open at the same time, to always receive the actual state of the board. We want to make sure that we're not predicting what the state's going to be. We're actually going to notify that device if it's on or off. And that way we can also just handle certain events too if we can't get connected or those kind of things. So that's pretty much goes over the Arduino code here. I know that was a lot to take in. I went ahead and posted the gist of all of this on my GitHub, as I mentioned earlier. So feel free to browse through that and look through the documentation from Nick O'Leary if you have any questions on what that MQTT stuff is doing. So now that we have all of this set up, let's just take a look. We can test this right away and make sure that all of this is working.
Okay, so after we've grabbed that template and filled in the Wi-Fi network name, password, and all of the MQTT client info from our CloudMQTT account, we should be good to go. So basically what we need to do is connect our board to our computer, flash the program on, and at the very beginning we're not going to really notice anything breaking, change, anything different. Our lights are still going to turn on and off, right? But the one true difference is going to be how we can now control it through the CloudMQTT. So I'll go ahead and try to show you this here while I get my light. You'll still be able to see this there in the corner. First thing to do is when you're in MQTT is to go to the WebSocket UI. This will allow us to basically send messages to our device. So you can see after I've done that I've already had some light state changes. I've already been receiving some of the messages already just by toggling the switch. And when I go on and I say with the topic of light on, I send this message, you can see that the light now turns on. Now this is completely independent. This is just listening. Remember, in our code, it's listening for that topic of light, and the power on and off is based off of whether or not I have it set to on or off. You can also see that the light state is also getting sent back. Now this is important for, like I was saying in the UI, our phone app or our web app to actually update the true state of the device. And you can see when I turn this on or off that this is also getting sent to our device. So this would allow us to control it both from the device itself or from a web app. So now the next step would be, now that we know that it's working, let's go ahead and get a web app and a phone app going so that we can finally complete our project. And to do this, I'm going to use Xamarin and Visual Studio. I will go ahead and go over some of that in the next pieces. If you're having problems connecting to this, I recommend using the serial output on Arduino. We already have logs in the template to tell you whether or not you're getting connected to your device. And the CloudMQTT stuff, you might need to add some logging to see if it's there. So, but if something is not working at this point, you certainly need to take a step back and double check that everything is set up properly before moving on to the next step. So with that said, let's go ahead and wrap up our IoT with Xamarin apps.
We're going to create our applications to control the light switch, and for this I'm going to use Visual Studio and Xamarin. And if you're not familiar with Xamarin, it's a .NET extension that basically allows you to create iOS, Android, and web apps all with C# code. And basically we can put all of our logic using C#, and then all we have to do is use some of the front, we just have to implement some of the front end changes, and that's it. So inside this project, which I posted on GitHub, we have a core shared library. This is going to allow us to kind of put some of our core shared logic, and then all we have to do is in both our iOS and web is use that. We won't only have to write it once, we can use it in two. If I wanted to add an Android project, I could add that and then connect to this MQTT client as well. So let's go ahead and dive in on this. I created my own MQTT client class, but essentially it's an extension off of this NuGet package of MQTT net. They allow you to connect to clients much like our Arduino PubSub client. This is the C# version of that. So before we get started, you'll want to replace the MQTT details. This would be the same thing you did on the Arduino. So you're just doing that in here. If I were to basically do this as a serious project, I would probably pull all this out into a config file. Make sure when you change this, don't check this stuff into source control, because obviously user passwords, that would be a bad idea. But just for fun, and as long as you're not checking anything in, this is a quick way to get off the ground with that. A lot of this code I grabbed from the example projects on the documentation for MQTT.net. So it looks a little intimidating, but just remember there's some documentation there that I can share with you as well. But the main things in our shared library that we really care about are publishing and subscribing. And this is very similar to the Arduino. We're doing essentially the same thing, right? But we want to make sure that we are subscribed to changes that come from the light switch so we can change the UI. And we also want to make sure that we publish those for when we click like a button on our iOS app, that would get sent to our device as well. Okay, so taking a look at our iPhone app, you can see this is super simplistic. Just a label and a toggle. This isn't, I didn't set up any constraints for iPad, iPhone, different types of things for the layout. So just something to get off the ground and running. If you've ever been in Xcode before, you'll know that the toolbox exists and you can search through different things like a label, and then you can just drag and drop this to your storyboard. The other element was I always mess this up, the switch. And that one you can put in. Now, I the very first time I did this, I realized that the switch, as soon as you push the button, instantly toggles the state to on or off, right? And the thing is that we want to make sure our device is actually that this is reflecting the actual state of the device. So what I had to do is overlay the switch with a button and then basically have an event handler that will control the switch. So just a little heads up there on why there is a button over the switch. That's just kind of to help cover up the handler, and then that way I can handle the switch independent of the default behavior. Over here in the view controller, you can see that we brought in our MQTT client from our shared library. I just added the reference here to the iOS project, and we'll go ahead and new up an instance of that. Our topic received event, what we will go ahead and do is attach our event listener to that. And if we didn't really look at this necessarily right away, or in detail, but when we subscribe, we actually go ahead and just say when we get that topic to fire off this certain event. That's why this is smart enough. Like in the Arduino one, we would have to actually filter the payload, and since we only have one topic we're subscribing to, I'm not going to go ahead and do that. This would have to be modified if you were subscribing to multiple topics because you only have one event listener. So just be aware of that. But since we can subscribe to that, that means that any of these light state events will actually hit this payload. And then from there, we're just checking whether the payload is on or off and setting the state off of that Boolean. Then this is our button that I was telling you about. So that way we're going to have our button basically publish the inverse of what our state is. So if the button was on, we're going to go ahead and set that we want to switch it to off, and likewise the other way around. And that's it. Because the shared library is taking care of most of our heavy lifting, we're able to have very little code inside of our iOS application.
Okay, so we've got this fired up on our simulator running a debugger through Visual Studio. As you can see, our very minimalist UI here, and running this on an iPhone 10 to match my physical device. You can see we've got our label, and then we've got our switch. Now right now over here we do have our device plugged in and it is running. So to test this out then, all we are doing is if we click the on, you can see that the light bulb has turned on, off, the light bulb has turned off. And then on the physical device, this should work two ways then now. When I click on, you can see that gets reflected on our iOS device, and same with turning it off. So the state is always maintained on and off, and everything is working here. So we're looking pretty good. Next thing, let's go ahead and switch over and see if we can get this running on a web app as well.
Okay, so just on our main index page, which is our default route, went ahead and just added just a very simple HTML layout. And within this, we just are going to have I decided to use Font Awesome and create a button that would have kind of a power on off effect. And much like with our iOS stuff, we went ahead and bound that value to a variable. And that's pretty much it. You'll see a lot of our similar code here. Here's our client again from the shared library. And basically, once again, when we initialize our app, if we don't have a MQTT client, we'll go ahead and new one up here. Now it's important to note that this on initialize async runs multiple times, which is why we went ahead and added this if block here. But similar to our iOS, we're going to do the exact same things. We got to figure out what happens when we receive a topic. We need a method for that. And then we also need to subscribe for updates. So basically, here's our callback we get with our topic. If it's on, we're going to set our variable to true, else false. And then we're going to go ahead and fire off the state has changed. This will allow our checkbox to fire on and off. I found with Blazor, this was actually kind of a sticking point with Blazor, that the state usually gets triggered by like click events or text events, things like that with inside our app. But when the state gets changed from like an event handler you basically have to manually fire this off. I've really tried to do something else without this. I thought it would automatically bind. That is not the case. And then we have to handle our actual button. So much like with um, iOS, we're able to bind our button to a event. We went ahead and did that here as well. So basically, keeping track of our state, we just reverse the state, and then we publish whether it is on or off. So we'll go ahead and fire this thing up and take a look.
Okay, so here we are in our web interface, and I went ahead and did something a little different than our iOS. I went ahead and added a circular power button with a status below it as well, and that's pretty much it. Nothing too fancy. I'll go ahead and pull out here so you can see the light switch as well. And basically similar to the iOS, if we click the power button, you can see that the light switch was turned on, and similarly when we turn that off, likewise the physical button, turning that on will also trigger the indicator on and off. So there we have it, the project pretty much complete there. The nice thing is now we can also take a look if we had both running at the same time. So I went ahead and fired up. I've got my iOS app, my web app, and also the physical light on here. If I click the iOS, you can see that now the web light is on as well as the physical light. I can power that off between here, and that will turn off all of those. And once again, also on the physical device, I can turn that on, and that state is reflected across everything. So there you have it. This project here is just kind of an intro. It's been a great learning opportunity for Blazor and Xamarin and IoT, and I hope you've enjoyed it. If you have any comments, questions, problems with the code, just let me know, and thanks for watching.